So in the last video, we learned how to multiply matrices, what dimensions they need to be, and how that operation actually works. We worked through one example, and so in this video, let's just work through a few more examples to get a better feel of how to multiply matrices. Okay, so in the first example, we took matrix A times matrix B. We knew that we could do that because the dimensions of my rows of my first matched the dimensions of the columns of my second. All right, let's see what happens when I want to reverse the order. What happens if I take B times A? Well, if we're thinking that it is commutative, that we can just rearrange the order and get the exact same thing, this is where I told you to be careful, because this is not necessarily true when you are multiplying matrices. Okay, so my matrix B has the dimensions of 3 times 2. And I want to try and multiply that by matrix A, which has the dimensions of 2 times 3. Well, for us to be able to do this, my inside dimensions must be able to match, and they do. And I'm going to end up with something of my outside dimensions. So notice I'm actually going to end up with a 3 by 3 here. So something that has completely different dimensions than I saw in my first example. In my first example, I ended up with a 2 by 2. So we learned that matrix multiplication is not commutative. We can rearrange the order and get something completely different. Okay, let us see if we can work through this. So let's see if I have enough room here. All right, so I'm going to take my rows of my matrix B, and I'm going to match that with my columns of matrix A. So always rows of the first times columns of the second. So I'm going to take my row of matrix B, and I'm going to partner it up with my column of matrix A. So that means I have 1 times 3 plus 6 times 2. Okay. So next, if I keep the same row with my second column, then I'm going to stay on my same row. I'm just going to move to my second column. Okay. So in this one, I have 1 times 1 plus 6 times 0. Again, it's like I'm taking this row and I'm partnering it up with this column here. Next, I do my same row times my third column. So same row times my third column. So that's where I'm going to end up here. So I have 1 times negative 1 plus 6 times 3. I ran out of columns, so that's where this matrix is going to end. So at this point, I see I have 3 columns. Okay, I've done all my rows, or I've used up this row in matrix B, so let me move to my second row in matrix B. If I move to my second row here, then I'm going to move to my second row here. If I partner it with my first column, then that means I'm going to partner it with my first column. So I'm going to put my math here where these two line up. So I have 3 times 3 plus a negative 5 times 2. Well, let me switch my columns. So I'm going to switch my columns. That gives me 3 times 1 plus a negative 5 times 0. And then last, if I do my last column here, which moves to my last column here, that is 3 times negative 1 plus negative 5 times 3. Okay? And then I need to switch to my last row in matrix B. So my last row in matrix B, starting with my first column, last row, first column, leaves me with negative 2 times 3 plus 4 times 2. Next column, leaves me with negative 2 times 1 plus 4 times 0. And last column. Negative 2 times negative 1 plus 4 times 3. And so you can see here my dimensions are 3 by 3. Now, if you look at this, everything should be lined up nice and neat. Notice all of my numbers here are the same. Well, that's because they line up with this column here. Same thing, all these numbers here are the same because they line up with these here. And then last, all of these numbers here are the same because they all line up with all of those numbers there. So you can see that it kind of follows a system. Well, if I were to look at it in a different manner, all of these numbers here, the 1, 6, 1, 6, 1, 6, is from this. All these numbers here, 3, negative 5, is from this. All of these numbers here, negative 2, 4, is from this. So you can very easily see if you've made any simple mistakes by using incorrect numbers because it should have that pattern all the way through. Well, now all we need to do is our basic multiplication and addition here. All right. So 3 plus 12 gives me 15. 1 plus 0 gives me 1. Negative 1 plus 18 gives me 17. 9 minus 10 gives me negative 1. 3 plus 0 gives me 3. Negative 3 minus 15 gives me negative 18. Negative 6 plus 8 gives me 2. Negative 2 plus 0 gives me negative 2. And 2 plus 12 gives me 14. And so I have my final answer of B times A, my 3 by 3 dimensions matrix. And so again, you see that A times B is not the same thing as B times A. They are very different. So matrix multiplication is not commutative. We cannot switch the order around, and it will make a difference if we try to do so. Okay, I had a couple more examples of this, so let me pull those up here. A times C and then B times C. So I suggest for you to pause the video and see if you can mimic this multiplication operation all on your own. Okay, so first one is A times C. I need to make sure that my dimensions will match. So this one is 2 rows by 3 columns. This one is 2 rows by 2 columns. So my number of rows does not match my number of columns. So therefore, I cannot multiply because they have incorrect dimensions. All right, and now let's try B times C, okay? So B is 3 rows by 2 columns, and here, C again was 2 by 2. My number of rows times my number of columns does match, and so I will end up with a 3 by 2 matrix. And so let's see if we can do that and get in. And so let's see what happens when we actually do that multiplication out. Okay, so again, I do my rows of my first times my columns of my second. So maybe we can start to skip some steps here. I have 1 times 4, which is 4, plus 6 times 1, which is 6. Switch to my next column. I have 1 times negative 6, which is negative 6. Plus 6 times 2, which is 12. I have 3 times 4, which gives me 12, plus negative 5 times 1, which is negative 5. Next, 3 times negative 6 gives me negative 18, plus negative 5 times 2 gives me negative 10. Here, -2 times 4 gives me -8, plus 4 times 1 gives me 4. And then my very last entry will be -2 times 6, which gives me 12, plus 4 times 2, which gives me 8. And so all I need to do is simplify this. So this gives me 10, 6, 7, -20, 8, -4, and 20. And so there is my 3 by 2 dimension when I multiply matrix B times C. All right, so we've done several examples of multiplying matrices. Again, the very first step is to make sure the dimensions match up properly. The number of rows in the first needs to match the number of columns in the second. If not, then you cannot do that multiplication. And if so, you just match up those respective entries. All right, when we come back, we're going to be talking about more properties of matrices, and then we're going to actually see some examples of where we would actually use some of these matrix operations.